Washington State electrical exam consists of 3 parts. Firstly, the National Electrical Code or NEC section involves 65 questions with a 4-hour time limit. This section is generally considered easier, with questions following a chronological order within the codebook. Expect some theory-based calculation questions. An Ugly's book can be a helpful reference. Secondly, the Washington Administrative Code or WAC and Revised Code of Washington or RCW section contains 17 questions with a 1-hour time limit. This section is typically more challenging. Familiarity with the location of concepts within the codebook is crucial. Questions cover continuing education requirements, the electrical board, and appeal processes including any associated time limits. Thirdly, the Major Calculations section presents 10 questions with a 2-hour time limit. This section is considered the most difficult. Calculation types include duplex dwellings using the standard method with 2 questions dedicated to this. Multi-family dwellings using the optional method with 2 questions. Note that these calculations do not involve house or laundry loads. Feeder overcurrent protection size for motors, specifically with 4 motors using an inverse time breaker. Receptacle quantities for both commercial and residential applications. This includes calculating the number of 20 amp 120 volts receptacles required for a 2,000 square foot church and the number of 15 amp 120 volts receptacles required for a 4,000 square foot single family residence. Demand factor calculations for 3 ovens and a cooktop wall with a kilowatt rating between 8.75 kilowatts and 12 kilowatts. An industrial load calculation for a 2-tenant building with a variety of loads which is notably complex. When approaching the duplex standard method calculations, be prepared for unconventional answer options. For the multi-family optional method calculations, remember that house and laundry loads are excluded. When calculating the feeder overcurrent size for motors, ensure you correctly apply the NEC rules for motor full load currents, conductor ampacity, and overcurrent protection. For receptacle quantity calculations, refer to the NEC requirements for general lighting and receptacle outlets in commercial and residential occupancies. Accurately determine the square footage and apply the appropriate demand factors. For the demand calculation involving ovens and a cooktop, use the demand factors provided in the NEC for household cooking appliances. The industrial load calculation for a 2-tenant building requires careful consideration of all connected loads, including lighting, receptacles, HVAC equipment, and any other specialized equipment. Apply the appropriate demand factors for each load type based on the NEC requirements. The NEC provides guidelines for calculating the minimum number of general-purpose receptacle outlets required in various types of occupancies. These requirements are based on the square footage of the space and the intended use. For dwelling units, the NEC specifies that receptacle outlets must be installed so that no point along the floor line of any wall space is more than 6 feet, measured horizontally, from an outlet in that space. This ensures that extension cords are not used as a substitute for permanent wiring. In commercial buildings, the NEC requires receptacle outlets to be installed in accordance with the specific needs of the occupancy. For example, in office buildings, receptacle outlets must be installed along each wall space that is 2 feet or more in width. In retail spaces, receptacle outlets must be installed to accommodate the display and use of merchandise. In addition to the general requirements, the NEC also includes specific requirements for receptacle outlets in certain locations such as kitchens, bathrooms, and outdoor areas. These requirements are designed to protect against electric shock and other hazards. When calculating the number of receptacle outlets required for a specific project, it is important to consult the NEC and any applicable local codes. These codes will provide the specific requirements for the type of occupancy and the location of the receptacle outlets. In addition to the minimum requirements, it is often necessary to install additional receptacle outlets to meet the needs of the occupants. This is particularly true in commercial buildings where there may be a large number of electrical devices in use. When determining the appropriate number of receptacle outlets, it is important to consider the current and future needs of the occupants. For the motor feeder overcurrent protection calculation, consider the following steps. Firstly, determine the full load current or FLC of each motor from NEC table 430.248 or 430.250. Secondly, calculate the sum of the full load currents of all motors. Thirdly, determine the largest motor full load current. Fourthly, calculate the conductor ampacity. The minimum feeder conductor ampacity is 125% of the largest motor FLC plus the sum of the remaining motor FLC. Refer to NEC section 430.24. Fifthly, select the appropriate conductor size based on its ampacity from NEC table 310.15b16, considering the temperature rating of the terminations. Sixthly, determine the feeder overcurrent protection size. The maximum feeder overcurrent protection size using an inverse time circuit breaker is the sum of the full load currents of all motors plus a percentage of the largest motor FLC as specified in NEC section 430.52. This percentage depends on the type of motor and its horsepower rating. Seventhly, select the standard size overcurrent device. If the calculated value does not correspond to a standard size, you are permitted to go up to the next standard size as per NEC section 240.6, provided that the conductor ampacity is not exceeded. For multi-family dwelling calculations using the optional method, here is the breakdown. Firstly, determine the total square footage of the dwelling units. Secondly, calculate the general lighting load. The NEC specifies a minimum lighting load of 3 volt amps per square foot for dwelling units. Thirdly, calculate the small appliance branch circuit load. The NEC requires a minimum of 2 20 amp small appliance branch circuits for the kitchen and dining areas of each dwelling unit. This equates to 1500 volt amps per circuit, totaling 3000 volt amps. Fourthly, calculate the laundry branch circuit load. The NEC requires at least 120 amp laundry branch circuit for each dwelling unit, which equates to 1500 volt amps. Fifthly, calculate the electric range and cooking appliance load. Use NEC table 220.55 to determine the demand factor for electric ranges and cooking appliances based on the number of units. Sixthly, calculate the electric dryer load. If electric dryers are installed, use 5000 volt amps or the nameplate rating, whichever is larger, for each dryer. Apply demand factors from NEC table 220.54 if applicable. Seventhly, calculate the heating and air conditioning load. Determine the total connected load for heating and air conditioning equipment. Apply demand factors from NEC sections 220.50 and 220.51 as applicable. Eighthly, calculate the total calculated load. Sum all the loads calculated in the previous steps. Ninthly, determine the service or feeder size. Divide the total calculated load by the voltage of the service to determine the minimum required ampacity. Select the appropriate conductor size and overcurrent protection based on this ampacity, considering voltage drop and other factors. For a duplex dwelling calculation using the standard method, follow these steps. Firstly, calculate the general lighting load using 3 volt amps per square foot as per NEC section 220.12. Multiply the square footage of the dwelling by 3 volt amps per square foot to determine the general lighting load. Secondly, calculate the small appliance branch circuit load. Each dwelling unit requires a minimum of 220 amp small appliance branch circuits for the kitchen and dining areas. Each 20 amp circuit is rated at 1500 volt amps, totaling 3000 volt amps. Thirdly, calculate the laundry branch circuit load. Each dwelling unit requires at least 120 amp laundry branch circuit rated at 1500 volt amps. Fourthly, calculate the electric range load. If the dwelling units have electric ranges, use NEC table 220.55 to determine the demand factor based on the kilowatt rating of the ranges. Fifthly, calculate the electric dryer load. If the dwelling units have electric dryers, use 5000 volt amps or the nameplate rating, whichever is larger, for each dryer. Sixthly, calculate the heating and air conditioning load. Determine the heating and air conditioning load based on the connected load of the equipment. Apply any applicable demand factors as per NEC sections 220.50 and 220.51. Seventhly, calculate the total load for each dwelling unit. Sum all the loads calculated in the previous steps for each dwelling unit. Eighthly, calculate the total service load. Sum the total loads of both dwelling units to determine the total service load. Apply any applicable demand factors as per NEC Article 220. Ninthly, determine the service entrance conductor size and overcurrent protection. Divide the total service load by the voltage of the service to determine the minimum ampacity required. Select the appropriate conductor size and overcurrent protection based on this ampacity, considering voltage drop and other factors. For calculating the demand load for multiple cooking appliances, follow these steps. Firstly, identify the rating of each appliance. Determine the kilowatt rating of each cooking appliance, including ovens and cooktops. Secondly, use NEC Table 220.55. Refer to NEC Table 220.55, which provides demand factors for household cooking appliances. The demand factors vary based on the number and rating of the appliances. Thirdly, apply demand factors. Apply the appropriate demand factors from Table 220.55 to the kilowatt rating of each appliance. Fourthly, calculate the total demand load. Sum the demand loads of all the cooking appliances to determine the total demand load. Fifthly, determine the feeder conductor size and overcurrent protection. Based on the total demand load, determine the appropriate feeder conductor size and overcurrent protection, considering the ampacity of the conductors and the rating of the overcurrent device. When dealing with an industrial load calculation, there are important considerations. Firstly, collect load data. Gather detailed information on all electrical loads within the two-tenant industrial building. This includes lighting, receptacles, HVAC equipment, machinery, and any specialized equipment. Secondly, determine the demand factors. Apply appropriate demand factors to each type of load based on NEC Article 220 and any applicable local codes. Demand factors account for the fact that not all loads will be operating at their maximum simultaneously. Thirdly, calculate the lighting load. Calculate the total lighting load based on the square footage of the building and the lighting requirements for each area. Use NEC tables to determine the appropriate lighting load per square foot. Fourthly, calculate the receptacle load. Calculate the total receptacle load based on the number and type of receptacles in the building. Use NEC tables to determine the appropriate receptacle load per outlet. Fifthly, calculate the HVAC load. Calculate the total heating, ventilation, and air conditioning or HVAC load based on the size and type of equipment. Obtain the nameplate ratings of the HVAC equipment and apply any applicable demand factors. Sixthly, calculate the motor load. Calculate the total motor load based on the horsepower and quantity of motors in a building. Use NEC tables to determine the full load current of each motor. Apply demand factors based on the type of motor and its application. Seventhly, calculate the other loads. Calculate any other significant electrical loads, such as welders, electric furnaces, or specialized equipment. Obtain the nameplate ratings of the equipment and apply any applicable demand factors. Eighthly, calculate the total connected load. Sum all the individual loads calculated in the previous steps to determine the total connected load of the building. Ninthly, apply demand factors to the total connected load. Apply appropriate demand factors to the total connected load based on the type of occupancy and the diversity of the loads. This will result in the total demand load of the building. Tenthly, determine the service entrance conductor size and overcurrent protection. Based on the total demand load, determine the appropriate service entrance conductor size and overcurrent protection. Consider the ampacity of the conductors, the rating of the overcurrent device, and any applicable voltage drop requirements. During the exam, time management is critical. Allocate your time wisely among the different sections and questions. If you encounter a difficult question, don't spend too much time on it. Move on to other questions and come back to it later if you have time. If time is running low, make an educated guess rather than leaving the question blank. Remember that thorough preparation, familiarity with the NEC, and effective time management are key to success on the Washington State electrical exam.